This is SOSF. Let's just take a breath for a second. Step away from the noise. We need to talk about something that's happening right now, under the surface of everything, that is going to define the rest of our lives. I'm not kidding. This is bigger than politics. It's bigger than the squabbles we see on the news. This is about the brains. The silicon brains that are going to run the future. We're talking about the silent, high-stakes war for AI chip supremacy. You hear about AI all the time. It's writing articles, it's making art, it's diagnosing diseases. But what is it, really? At the end of the day, AI is a hungry beast. And what it eats is computing power. It needs to process insane amounts of information to learn, to get smart. And the company that's been serving up the all-you-can-eat buffet for this beast is Nvidia. You might know them as the guys who make the graphics cards for your gaming PC, right? So you can see every blade of grass in some insane fantasy world. Well, it turns out that the same kind of chip architecture that's amazing at rendering a dragon setting a village on fire is also ridiculously good at doing the math for artificial intelligence. It's all about doing a million tiny calculations all at the same time, in parallel. And Nvidia, man, they are the undisputed heavyweight champion of the world at this. They're not just the champion, they're like Mike Tyson in his prime, and everyone else is just trying not to get knocked out in the first 30 seconds. They have something like 90+% of the market for these high-end AI chips. It's a crazy monopoly. So, when we talk about this race, you gotta understand what the other side is trying to catch. Nvidia isn't just sitting still, counting their money. They're a moving target that's accelerating. It's like they're on a rocket ship, and everyone else is trying to catch them on a bicycle. Check this out, just to give you a sense of the speed we're talking about. A couple of years ago, their killer chip was called the H100. This thing was a monster. The whole world was fighting to get their hands on them. Companies were spending billions. But then, in 2024, Nvidia just drops the mic and unveils the next generation, the B200. And it's not just a little bit better, it's a completely different animal. The old chip, the H100, had 80 billion transistors. Now, a transistor is like a microscopic light switch, the fundamental building block. 80 billion of them. Mind-boggling, right? Well, the new B200 has 208 billion. It's a 2.6x jump in the sheer density of the thing. The amount of raw horsepower, the number of calculations it can do, is more than double. And think about the memory. An AI model is a huge, complex thing. You need to be able to fit it into the chip's memory to work with it efficiently. The H100 had 80 gigs of this super-fast memory. The new B200 has 192 gigs. That's a game changer. It means AI developers can build bigger, more powerful brains without having to do all these complicated, slow workarounds to chop the model up into smaller pieces. It's the difference between having a regular-sized workbench and having a gigantic aircraft hangar to build your project in. You can just do things that were impossible before. So even if some competitor, say, a huge state-backed effort from a country like China, managed to build a chip today that was as good as the H100, which would be a monumental achievement, a genuine miracle, they'd still be 2 years behind. And they'd be behind a company that's not just taking steps, but giant, pole-vaulting leaps. The gap is getting wider, not smaller. But here's the real crazy part. That's just the hardware. That's just the physical chip. Nvidia's real, unkillable advantage, what the business guys call the moat around their castle, is the software. It's this thing called CUDA. Now, stay with me here. This is the secret sauce. Imagine if for the last 20 years, every single mechanic in the world was only trained to work on Ford engines. All the tools in every garage were made for Fords. All the engineering textbooks in every university taught the Ford system. All the factories were set up to build Fords. And you, with your brand new car company, you come out with a revolutionary new engine. It's amazing, it's faster, it's more efficient, but nobody knows how to fix it. Nobody has the tools for it. Nobody knows how to build software for it. You'd have to retrain an entire generation of engineers and mechanics and convince every company to throw out their old tools and buy yours. It's an impossible task. That's CUDA. It's the programming language, the set of tools, the libraries of pre-written code that every single AI researcher, every PhD student, every data scientist in the world has learned to use for the last 2 decades. They literally think in CUDA. Their entire workflow is built around it. For a company to switch, they'd have to rewrite decades of code, retrain their entire staff, and take a massive risk that the new thing will even work right. The switching cost is astronomical. It's not a technical problem. It's a human problem. It's institutional inertia on a global scale. Nvidia built the roads, and now everyone has to drive on them. And this all feeds itself. Because they have the best hardware and the only software anyone wants to use, they make insane amounts of money. We're talking about a market that's going to be worth $500 billion by 2030. Their profits are so huge that they can pour billions back into research and development, more than all their competitors combined, which guarantees that their next chip will also be the best. It's a virtuous cycle, a flywheel that just spins faster and faster. On top of that, they get this wild workload insight advantage, because all the top AI labs, the people creating the next version of these powerful AIs, have to work with Nvidia. Nvidia gets a sneak peek into the future. They see what kind of problems these new AIs are trying to solve, what kind of math they need to do. So they can literally design their next chip to be perfectly optimized for the AIs of tomorrow, while everyone else is still trying to catch up with the AIs of yesterday. It's like the house always knowing your next hand in poker. You just can't win. So that's the fortress. That's Castle Nvidia. A relentless pace of hardware innovation, a software ecosystem with a death grip on the entire industry, and a financial machine that just prints money to fuel the whole thing. This is the challenge facing anyone who wants to compete, and specifically, the challenge facing China. Now, on the other side of the world, this isn't just a commercial competition. It's a matter of national destiny. The Chinese government has looked at this situation, seen their complete dependence on American technology for the most important resource of the 21st century, and they've decided, absolutely not. We are not going to be at the mercy of another country for this. So they've launched this all-out, state-driven campaign to achieve what they call AI sovereignty. The centerpiece of this is a massive national investment fund. Think of it as a national war chest for technology. They just launched the third version of it, and it's about $48 billion. That's with a B. And they've gotten smarter about how they're spending it. The first two funds were all about just building more chip factories, trying to brute force their way into manufacturing. But they realized that's not enough. You can have the fanciest kitchen in the world, but if you have to import all your ingredients, your knives, and your recipes, you're not really independent, are you? So this new fund is targeting the choke points. They're not just funding the factories, they're funding the companies that make the super specialized equipment that goes inside the factories. They're trying to build their own versions of the machines that make the machines. They're trying to develop their own versions of the incredibly complex software that you need to even design a chip in the first place, software that's currently dominated by American companies. They're playing the long game. It's a more difficult, more fundamental approach, but they know it's the only way to truly break free. And you're starting to see the champions of this national effort emerge. There's one company in particular, a massive telecom giant that's already been in the crosshairs of the US government. They are the designated national champion. They're trying to do it all, the full stack. They're designing their own AI chips, called the Ascend series. And their latest chip is genuinely impressive, for what it is. On paper, it has more memory than Nvidia's H100, which is a big deal for large AI models. Its raw computing power is getting close, maybe in the same ballpark. It's a legitimate contender. And they're also building their own software ecosystem, their own version of CUDA, to go with it. They are, from scratch, trying to replicate what Nvidia has built over 20 years. An absolutely monumental task. Then you have other players trying different strategies. There's a fascinating startup that's taking a more guerrilla-style approach. Their whole pitch is software compatibility. They built a data center chip that's, it's fine. It's not going to set any speed records. It uses cheaper, slower memory. But their secret weapon is a piece of software they call a translation layer. They claim that you can take code written for Nvidia's CUDA, run it through their translator, and it will automatically work on their chips. They market it as a zero-cost migration. They're not trying to beat Nvidia on a drag race. They're trying to attack the moat. They're trying to pick the lock on that software prison. It's a clever idea, but these kinds of translators are notoriously tricky. They almost always have performance issues, bugs, and they're always a step behind the latest features. It's a good enough solution, not a world-beating one. But all of this, all the clever designs and all the billions in government funding, smacks headfirst into the biggest, hardest wall of all: manufacturing. This is the part of the story that's just brutal. Designing a chip is one thing. Actually making tens of thousands of them perfectly is another. It's a completely different universe of difficulty. And the gap here between the world leader, a company in Taiwan we can call the TSMC, and the top factory on the Chinese mainland, is not a gap, it's a chasm. It's the Grand Canyon. The TSMC in Taiwan are already mass-producing chips on what they call a 3-nanometer process. In 2025, they'll be on 2 nanometer. By 2028, they're talking about 1.4 nanometer. These numbers are almost meaningless. They're so small. We're talking about building circuits where the components are the size of a few dozen atoms. To do this, they use a technology that is straight out of science fiction: EUV, or extreme ultraviolet lithography. It's a machine the size of a city bus that uses super powerful lasers to create a specific wavelength of light to etch these impossibly tiny patterns onto silicon wafers. There's only one company in the world that makes these machines, a Dutch company called ASML. And because of US export controls, they are forbidden from selling these machines to China. Full stop. So, the mainland factories are stuck. They can't get the magic EUV laser scalpel. They have to use the older technology, called DUV. To get to the same small feature sizes, they have to use all these incredibly complex workarounds, basically shining the light multiple times in different patterns to slowly carve out the shape they need. Imagine trying to perform microscopic surgery with a blunt instrument. You might be able to do it, but it's going to be slow, expensive, and you're going to mess up a lot. And that's exactly what's happening. The yields, the percentage of chips on a wafer that actually work, are reportedly below 50% for their advanced 7 nanometers process. At the TSMC, yields are well over 90%. And the cost for a finished wafer on the mainland is 40 to 50% higher. So even when they manage to produce a chip that is, on paper, similar to one from the TSMC, it's physically hotter, it's more power-hungry, and it's way more expensive. In a giant data center where your biggest costs are electricity and cooling, these chips are just not commercially competitive on a global scale. They're a strategic asset, for sure, but they're not going to take over the world. And this whole thing is happening on a battlefield that is actively being shaped by the US government. The export controls that went into place in October 2022 are a multi-layered technological blockade. It's not just you can't sell them your best chips, it's a full-spectrum attack. It's the ban on the EUV machines. It's rules based on performance thresholds, so even if a company designs a new chip, if it's too powerful, it's automatically banned. But the most potent, and you could say most insidious, part of the sanctions was the US person's rule. This rule says that any US citizen or green card holder is prohibited from working to support the development of advanced chips in China. This was a devastating blow. So much of the expertise, the hands-on, tacit knowledge of how to run these incredibly complex factories, was in the heads of engineers and executives who were educated in the US, had worked for US companies, and held US passports or green cards. This rule forced them to make an impossible choice: give up your career or give up your legal status in America. The result was an immediate, catastrophic brain drain. You can't replace decades of accumulated knowledge overnight. You can't buy that wisdom with a $50 billion check. It was a direct attack on the human element of innovation, and it has been brutally effective. China, of course, is pushing back. They're designing chips that fall just under the performance limits. They're trying to find loopholes, but this whole situation has created a bizarre paradox: the sanctions paradox. In the short term, the controls are absolutely working. They are slowing China down, no question. But in the long term, they are forcing China to do the one thing they might not have done otherwise: build a completely parallel, self-sufficient, non-American technology ecosystem. Before the harshest rules, their tech industry was deeply woven into the global supply chain. They were the biggest customers of the TSMC. They used American design software. They had a commercial incentive to play by the rules of the globalized system. The sanctions changed that. It became an existential threat. So now, the government has the political will and the financial backing to fund a decade-long, Apollo program-level mission to reinvent every single piece of the semiconductor industry from the ground up. The United States is essentially trading its current position of immense leverage for a future where it may have no leverage at all over a hardened, completely independent rival. The short-term pain is the catalyst for the long-term decoupling. So, where does this all go? What does this look like in 5 or 10 years? Can China actually catch up and surpass Nvidia by 2034? Well, if you talk to the experts, the most probable scenario is, no, they won't. The combination of Nvidia's accelerating speed, the unbreakable CUDA software moat, and the massive manufacturing chasm enforced by sanctions is just too much to overcome in that time frame. China isn't chasing a parked car, they're chasing a rocket that's firing on all cylinders. But that doesn't mean China's strategy fails. The most likely outcome is not a global victory for China, but a strategic success. They will succeed in building a good enough domestic ecosystem. They will have their own chips, made in their own factories, using their own equipment, running their own software. These chips might be a generation or two behind Nvidia's best. They might be less power efficient, but they will work, and they will power China's massive domestic AI market. The result is a bifurcated world. A technological iron curtain descends. On one side, you have the US and the rest of the world running on the Nvidia/CUDA standard. On the other, you have China and its sphere of influence running on a parallel, self-contained, and sanction-proof tech stack. Nvidia doesn't get surpassed, but it gets completely locked out of one of the biggest markets on Earth. There is, of course, a low probability, black swan scenario. A wild card: China is investing heavily in next-generation technologies that could potentially leapfrog the current paradigm. Things like advanced packaging, where you build a powerful processor by connecting smaller, simpler chiplets together like Lego bricks. Or the really sci-fi stuff, like silicon photonics, which uses light instead of electricity to move data around, potentially solving major bottlenecks in a way that's less dependent on those EUV machines. If they had a major breakthrough in one of these areas, it could change the game overnight. It's a long shot, but they're absolutely swinging for the fences. So when we look ahead to 2034, it's highly improbable that a Chinese-designed chip will be the best in the world, on a head-to-head basis with whatever monster Nvidia has cooked up by then. Nvidia's moats, especially CUDA, are just too durable. Their leadership in architectural design and their access to the absolute cutting edge of manufacturing will likely remain intact. The world that emerges from this conflict isn't one with a single, undisputed champion. It's a world with two champions in two different leagues that don't play each other. The era of a single globalized tech ecosystem for high-performance computing is probably over. We are entering an era of technological decoupling. And this is the reality we have to wrap our heads around. It's not just about who has the fastest chip. It's about building two fundamentally different foundations for the future of intelligence itself. Two separate, diverging paths for the development of AI. Which leads to a final, truly wild thought to leave you with. Forget about the hardware for a second. Think about the AIs themselves. What happens in 15 or 20 years, when an artificial intelligence that has been born, raised, and trained entirely within one of these digital ecosystems, an AI that has only ever read its own internet, learned from its own data, been shaped by its own cultural and political values, meets an AI from the other side? When an AI from the Western sphere interacts with an AI from the Chinese sphere for the first time? Do they find common ground? Do they even understand each other's logic? Do they compete? Do they conflict? What does a disagreement between two superintelligences, raised in completely separate digital worlds, even look like? We are laying the groundwork for that confrontation right now, and almost nobody is talking about it. It's a crazy thing to think about. See you next time.